Hello everyone, welcome back to my channel. Today we will see one of the question which asked in my coding round. So this question asked in Cognizant Coding Round. This is a one of the most asked matrix question in coding assessment. So I don't remember the exact wording of the original question, but I to remember the complete logic. So I've explained it in the same way it is generally asked in coding interview. So the actual problem statement is the question says that given square matrix of size n cross n, calculate the absolute difference between the sum of two diagonals. The first diagonal, known as primary diagonal, contains element from top left corner to bottom right corner of the matrix. That means it is a primary diagonal. Then second diagonal is known as secondary diagonal, contains element from top right corner to the bottom left corner. That is secondary diagonal. After that, our task is to determine the sum of both diagonal and print the absolute difference between these two sums. The absolute difference is defined as the sum of primary diagonal minus the sum of secondary diagonal. So the input, the first line contain as an integer n and representing the number of rows and column in a square matrix. That means n cross n. The next n line contains n space separated integer each. So the output in a single integer. Now the constraint is like that. So in the example, we take the input. So the first input 3 means that matrix size is 3 cross 3. These are the elements in given matrix. And this is the output. Now before jumping into the solution, let's first understand what exactly primary and secondary diagonal are. Suppose the input matrix is here the first input mean the matrix size is 3 cross 3. Now let's identify both primary diagonal and secondary diagonal. So the primary diagonal always goes from top left to bottom right, top left to bottom right, and the secondary diagonal it goes from top right to top right to bottom left. So it is primary diagonal and it is secondary diagonal. So the elements in primary diagonal is 11, 5 and minus 12. And the element in secondary diagonal are 4, 5 and 10. There is a sum of primary diagonal and secondary diagonal. Now the question asks for the absolute difference. So we calculate absolute difference of primary diagonal and secondary diagonal, that is 15. Now let's think about the approach. Most beginner immediately think that since this is a matrix, so we scan every element using two nested. But actually, we do not need to scan the entire matrix again. We just calculate the diagonal because diagonal elements follow fixed pattern. Let's understand that pattern. So primary diagonal is we sketch the matrix in IHA form in 0 or 1. Now observe that these are the indices of the matrix. Now observe the primary diagonal. So these are the indices of the matrix in which we observe the primary diagonal elements. So the primary diagonal elements is 0, 0, 1, 1 and 2. Can you notice something? The row of index and column are always same. Here I and J, I and J, I and J. I and J are equal. So we can use at the place of J, we can use I also. I comma I, I comma I, I comma I. So the formula become matrix I. That's why we can access every primary diagonal element just one row. So now we can visualize the secondary diagonal elements. Now let's look at the second diagonal. So the secondary diagonal is 0, 2, 1, 1 and 2, 0. So the indices are, these are the indices of secondary diagonal element. Can you notice something here? 2, 1 and 0. I means row and J means column. The row is 0, 1, 2. I is increases and J is decreases. So instead of writing all these values manually, we use the pattern just like we track into a reverse order. So in a reverse order, the size of matrix is n, n minus 1 minus I, where n is a size of matrix, I is a row. So n is 3 and initially I is 0. So the answer is 2. So here J is calculated for the first row and for second element 3 minus 1. Now I will be increment. So I will be increases by 1. So I become 1. Then here 1. So the answer is 1. Now J is again calculated. After that 3 minus 1 minus 2 equal to 0. So from this pattern we can calculate the column index that can be decreases automatically. That's exactly why we use n minus 1 minus I. Now, so how do we solve it? Since both diagonally use the same row, index I, we does not need two different traversals. A single loop can be enough for it. However, in this way, we can traverse the primary diagonal and secondary diagonal. So, for primary diagonal, we need a matrix I, and for secondary diagonal matrix I n minus 1 minus I. Since both diagonal use the row index I, then after that we keep adding the matrix. So with just one loop we get both sum together. This matrix makes solution simple and efficient. After that, how to think about it? What is the approach of? We see that we does not need to scan the full matrix. We only need to scan the primary diagonal and secondary diagonal in one loop. Since both diagonal element use I, so inside that loop we keep adding the matrix I in primary variable, and the secondary diagonal elements can be added into a secondary variable into one loop. So with just one loop we get both sum together. The loop is iterated from 0 to n minus 1 only once, updating both running sum together. Keep adding the values in both of the variable. Then now final step is we calculate the absolute difference between the primary and secondary diagonal elements. So in Java, for calculate absolute difference, we use math.abs built-in function that convert any negative value into positive value, just like math.abs minus 15. So the output become 15, which is exactly what this question asks. Let's understand the code. So first we import the scanner class because we need to take input from the user. So next we create our class that we already created and the main method. Since execution of every Java program starts from here, this object allows us to read input from the keyboard. So read the size of the matrix here and represent the size of the square matrix. After that, we create the matrix. Here, the two-dimensional array of size n store all matrix element in which. After that, we take the input of the matrix. To insert every element into the matrix, we use two nested loops. The outer loop moves through each row while inner loop moves through each column. Since every position I comma j needs to fill, the two loops are necessary here for the insert elements into the matrix. After that, we create a variable for diagonal sum. So we use two variables. One is primary and second is secondary. So primary store the sum of the primary diagonal and secondary store the sum of secondary diagonal. I use the long data type because if matrix size or value become very large, the sum may exceed the range of an input. So we using long to avoid the overflow. While taking input, we needed two loops because we had to visit every element. But we calculate only the diagonal. So we need only one loop because both diagonal follow a fixed pattern. So one loop is enough for it. So in a primary diagonal, both row and column indices are same, and the secondary diagonal, when row indices increases normally but column indices move in reverse. So we use n minus 1 minus I. Now after that we calculate the absolute difference. Now we subtract both diagonal sums. The result can be positive or negative. So it is a built-in function in Java. So it return always positive value. So after that we print the result and close the scanner. This closes the scanner object and release the system resources associated with it. It is a good programming practice to close resources after using. So we use sc.close. Now we run the program. So here we take matrix size 3 and elements are 11, 2, 4, 5, 6, 10, 8 minus 12. The output is 50. Try run the code with an example and see exactly how the value change step by step. We take input 11, 2, 4, 4, 5, 6, 10, 8 minus 12. The size of matrix 3 cross 3, that means n is 3. After that, taking all input, our matrix look like this. After that, we initialize the two variable. Primary is 0 and secondary also 0. Both sum are initially 0. First, we iterate from I 0 to n. For loop is iterated from 0 to n minus 1. So we use this for n minus. So the primary diagonal axis, so firstly I is 0, then matrix is 0, 0. So the primary will access 11. So 11 is added into a primary. 0 plus 11, that becomes a 11. After that, secondary diagonal, that access 0, that access I, n minus 1 minus 1. That means I is 0 and n is 3 minus 1 minus 1, that is 0 2. So 0 2 is 4. So 4 is added into a secondary. This is the first iteration of the for loop. After that, I plus plus I will become a 1. Now I is 1. So primary diagonal is matrix 1 1, which access element 5. So primary is already 11 and now matrix 1 1 is 5. So it is added into primary 11 plus 5, that is 16. After that, secondary. In secondary, matrix will become I is 1 and here n minus. That means n is 3 minus 1 minus 1. Sorry, here 0. I mistakenly write 1. So that is 1, 1. So value is 5. So in secondary variable 4 plus 5, it is 9. Now primary become 16 and secondary become 9. After third iteration, I is 2. In a primary matrix is 2 2, which access the element minus 12, and in a secondary the matrix is 3 minus 1 minus 2, that is 2 0, which access the element 10. So minus 12 is added into a 16, that is 4, and 10 is added into a 9, that is 19. Now the loop has completed because all diagonal element has been processed. Now loop end here. So the sum of primary diagonal element is 4 and the sum of secondary diagonal element is 9. So the absolute difference between them is 15. The absolute value convert negative number to positive number, because here answer is minus 15, but through the math.abs built-in function it converts into a positive value, that is 15. So it is the output of our program. Before we end today's video, I would like to share one more important point that can really helpful in coding round. Sometimes in a coding round maybe give a slightly different variation of the same question. They may mention that if the matrix size is odd, the middle diagonal element should not counted twice because it belongs to the both primary and secondary diagonal. For example, in a 3 cross 3 matrix, when we see the primary diagonal elements and secondary diagonal elements, the 5 come twice. So the element 5 count twice. They mention that if the matrix size is odd, the middle diagonal element should not counted twice because it belongs to the both primary and secondary diagonal. For example, in a 3 cross 3 matrix, 5 is repeated as a twice. So very simple way we find the center element. The center element, the size of matrix is 3, that is 3 cross 3 matrix, in which when we find the center element, that is n by 2 and n by 2. Here Java perform integer division, that is 3 by 2 and 3 by 2, that will become 1 1. If the question specifically ask you to count the center element only once, then after calculating both diagonal sum, you simply subtract this center element once because it has already been added to both diagonal. But remember, in today's question, we do not need to do this because the problem only asks us to find the absolute difference between the two diagonal sums. So always make sure to read the problem statement carefully before adding extra step. That's it for today's video. I hope this explanation helped you understand not only the solution but also an important interview variation of this problem. So I will see you in next.